In this video, we're going to look at scalar multiplication and vector addition and subtraction. And so we talked about the fact that a scalar is just a number. And so if you want to multiply a vector by a scalar, right, so we would use k for that vector, it's just a real number, a k for the scalar, and v would be the vector. When you multiply a vector by a scalar, you basically have a new vector, and it would be called the scalar multiple of that vector. If you want to find the magnitude of the new vector, you'd have to take the absolute value of k. Remember, magnitude is just a distance or a length, and so it's going to be positive. If you take the absolute value of k times the magnitude of the vector, you will get the new magnitude. In other words, if you multiply a vector by 2, basically what's happening is you're doubling the length of the original vector. So it's pretty straightforward. If you multiply a vector by -2, not only are you changing the magnitude, you're going to have twice the length, but you're also changing the direction. So when you multiply by a negative, you're reversing the direction. So let's look at some examples of scalar multiplication. So I'm going to start with vector v, which is this first vector right here. If I multiply that vector by 1/2, so the value of k is 1/2, really all I'm changing is the length of the vector. It's going to be half the length of the original. If I multiply vector v by 2, again, this is scalar multiplication. 2 is considered a scalar. I'm going to have the original vector, same direction, but double the length. Now, as soon as I change the sign of k, I'm changing the sign of the original vector. Not only am I changing the length or the magnitude, I'm also changing the direction. So you can see that 1/2 v is the same direction as the original vector, only half the length. But -1/2 v is not only half the length, but it's also going in the opposite direction. So when we add and subtract vectors, one way to do this is to do it geometrically by drawing a picture. And later on, we'll talk about how we can do this just basically algebraically.
So now let's add two vectors geometrically. In other words, we're going to add two vectors by drawing a picture. So I'm going to start off with vectors u and v. Now if I want to add these two vectors together, there's really only two steps. When we add two vectors together, the result is another vector, and we call that the resultant vector, or the sum. If I want to show u plus v, what I need to do is draw u and v so that the terminal point of u, which is right here, the terminal point of u is really basically the end, right? Where the arrow is. And I want to make sure that that coincides with the initial point of v. So I'm going to redraw these two vectors so that happens. So I've got the initial side of v coinciding with the terminal side of u. And then step 2 is to draw the resultant vector from the initial side of u to the terminal side of v, and this would represent the sum of the two vectors. Now, since addition is commutative, and this property holds true with vectors, if I wanted to add vector v plus vector u, I could do that by drawing v first and taking the initial side of u and starting at the terminal side of v. So here's my v, here's my u, and again now the initial, my resultant vector is going to start at the initial side of v. We're going to draw that to the terminal side of u. This would be the vector u plus v. So you can see that this vector has the same magnitude as the original sum that we did over here, and it has the same direction. All right, now let's look at a difference. So we know that adding the opposite is the same thing as subtracting. So in order to subtract, what we're going to do is we're going to look at multiplying a vector by -1. Right? We know that the opposite of a vector is the same thing as multiplying that vector by a scalar multiple of -1. If I want to take that same u and v, so we'll rewrite those. Here's my u, and here is my v. Right? Instead of taking u minus v, we want u plus the opposite, right, of vector v. So we know that the opposite of a vector, the vector will have the same magnitude but just the opposite direction. So if I want to write down what the opposite of v is going to look like, I'm going to take my initial vector here, make sure it has the same magnitude, and just draw it in the opposite direction. Now what I want to do is I want to take this u and add it to the opposite of v, really using the same strategy. I'm going to draw my u, and I'm going to make sure that the initial side of v, in this case the opposite of v, coincides with the terminal point of u, and I would draw my vector. And now the resultant vector would go from the initial point of u to the terminal point of negative v, giving me u minus v.